Now in this case we have to compare the dipole moment of the given molecule. Now when we see dipole moment is essentially a vector of electron displacement. So how do we compare A or B? Now what happens, let's say this is molecule A, the electrons are going to go in the outside the ring, so the dipole moment vector will be down, and here this is plus r over here at this end, so the dipole moment vector over here will be down. So these two are supporting vectors, and so is also the case in molecule B. Everything remains same except that the 4 methyl have now appeared. How do we compare this? How do we compare these two molecules? So this is a downward vector, this is downward vector, so they should have the identical, but it is not happening that way. So which means what? So because of this methyl, this repulsion, this nitrogen gets slightly outside the plane. So if you see from side, there would be a vector because of NO2 and there would be a vector because of N, but this has moved slightly outside the plane because of steric inhibition caused by of resonance, steric inhibition of resonance, the SIR effect. This because of this methyl molecules, this nitrogen has gone outside the plane. What happens in the first one? There is no methyls out here, so this will be in one plane. So we have two vectors v1 and v2 exactly aligned, and compare the situation over here. The v1 and v2 dash was, this is slightly outside the plane, so only the component of this vector is going to support, and therefore the net resultant would be less in this case and this will be more in this case, right? And therefore